Welcome you all. This video we are going to see execution mode of Python. There are two type of execution mode. First one is the interactive mode, another one is the script mode. In the interactive mode, when you are using a shell, it is a Python shell. Okay, you can directly type any valid Python instruction, then it is executed immediately. We can say that it is a interactive mode. Then another one is the script mode. The script mode, it consists of valid set of Python instruction. That is one or more valid set of Python instruction. These valid set of Python instructions are stored in a file with the extension .py, with the file extension .py. Then it is compiled and it generates a bytecode with the file extension .pyc, and you can use Python virtual machine to execute the bytecode with the help of Python libraries, and it returns a result as a machine code or executable code or running code. Okay, this is the execution mode of Python. Next we are going to see, we discussed execution mode. Next we are going to see input and output statement. The input and output statement, there are two statements are available for getting an input from user and returning a result using print statement. When you want to user read the data through input statement, similarly the processed result should be displayed using printf statement. I already told you that there are two types of execution mode, interactive mode, another is a script mode. Here we will see how this input and output statement working. First we will see how the print statement is working. Print is used to print the content. The help of printf is the printf is the method. Within that you can place any valid information. Welcome you all. Then it prints the particular string. You can also print the information along with the format specifier. It is also possible. Say for example, I want to print the string success is depends on 100% interest. Now this is a string. We have format specifier %d, and then you can put percentage, and then you have to which data we need to send for this format specifier. Okay, I need to send this A data. Then look at the success depends on 10. Normally we can say this is 100% interest, but what is the value of A? A value is just like 10. That's why the result is look like. If I am saying anything, A value is 100. Now you try to execute the same statement, print with format specifier. You can also use when you want to print percentage in that string itself, you can use double percentage. The success is depends on 100% interest. You can also print more than one information. It is separated by a comma operator. Hello, welcome. You can use the comma operator as the separator. You can use another format specifier with the help of an format function. Say for example, print, I can use the format function, then the string should be enclosed with the double quotes, and you can use curly brace, open curly brace, close curly brace. Within that you have to specify that index, it is a zeroth index. Yes, open curly brace, close curly brace, I can say that the first index. Dot format is the method. Within that you can pass the value. Say for example, I want to pass the two values, two strings. Love, it is assigned to the 0th argument, and the second argument I need to pass is the true. Then the true is assigned to the first argument. Every opening bracket has a respective closing bracket. You have to put closing bracket. Love is true. Okay, you can use the format method, or you can use percentage symbol for denoting the format specifier in the string itself. Then next is just like a script mode. The script consists of more than one valid Python instruction. Here there are two instructions: print welcome you all and print success. Okay, it displays the value as 100. Success is 100. And you can also write print all is well. Okay, similarly you can type n number of valid Python statements in the script mode. Okay, then you have to save the file with the extension. .py. Save as, and then you can give the file name and with the extension .py. Then it is ideally you can run this script with the help of an, when you are clicking run button and then when you are pressing the module, then it execute and it return the result in the cell prompt. Welcome you all, success is 100%, all is well. Okay, the next is the script mode demonstration. For that you have to open a new file. Okay, you need to save the file with the extension. We need to save the file with the file extension .py. I can say that it is a first.py. The file extension is .py. Okay, the file is already exist. You need to overwrite it. Yes. Now I have to write the valid set of instructions. Say for example, print first Python program, and I am getting the value is equal to input, enter the value, and I need to print some welcome message. Print welcome you all, and I need to print the message success is 100%. Then success, I need to use the format specifier. Percentage D is the format specifier. Then if you want to print the percentage also, you can use double percentage for printing the percentage symbol. And this is the string. Within the string, okay, this instead of this percentage, the content should be replaced. You can mention the format as a percentage, and then you can pass this value, pass the value. That is, this value should be assigned to this format specifier percentage D, and this one is used to print the percentage symbol. Okay, you have to save this file. After saving the file, okay, you have to execute. Okay, how you have to execute? In the sense, you can use a terminal in the command prompt. Okay, you can, where the file is located. Okay, the file is located at home directory. Okay, I can directly move to the home directory. Okay, now it is a home directory. Here you can check whether the file is available or not, and dir f star. Okay, the first.py is available. Then you can run the file with the help of an Python space. What is the file name? First.py. Then first program is displayed, and it entered the values. I can say that the value is 100. Okay, real number is required. The format and the type error is just like percentage D format is a real number is required, not a string, but we are passing a string. So what we have to do? We are getting some value and it is assigned into val variable. Okay, default we are getting the input as a string. Okay, you can necessarily conversion we need to use. Okay, I can say that I need to convert this string into integer. The string into integer. Now it is in the format of the real number. Okay, you can save this and then you just run it. In the terminal or command prompt, okay, Python first.py. The value is just like 99. Okay, welcome you all. Success is a 99%. Based on the value given, the value should be printed. Okay, these are the execution mode. Next, we are going to see variables. Variables is just like variables are not declared. Variables are not declared, just assigned. Variables are reference to an object. Everything in Python is an object. Type is used to denote the object information. So for example, saying that a is equal to 2. 2 is the integer object. It is assigned to a. Now, whenever we referring the a is denoting the integer object. Similarly, if I am saying that b is equal to 3. 3 is the integer object. It is assigned to b, and whenever you are referring b, it belongs to integer object. And I can use c is equal to a. Now, c is the object that reference to the a. You can check what is the identity of ABC. ID of a, then it has some memory location, just like for every object we have a unique memory location. For that integer object 2, we have memory location just like, and it is suffixed with 640. Okay, then you can check the ID of b. Then the 672 is the, it is ended with 672. And when you are referring, okay, so ID of C is pointing to the A. Then both A and C referring the integer object 2, then it has the same location it refers. That's why Python everything is an object. And if you take an object, okay, object has the identity, okay, it is unchangeable, and you can also check the type, it is also unchangeable, and the value you can change the value, okay, the value we can say it's a mutable. We discussed variables. Next we are going to see operator precedence and its associativity. Okay, Python has plenty of operators are there. Okay, here this diagram denotes from the highest precedence to lowest precedence are listed. Here the highest precedence operator is the exponentiation, and the lowest precedence operator is just like a logical operator. Now we can see one by one how these operators are useful. Say for example, if I am using exponentiation operator, then I can say that a is equal to 4. I want to use exponentiation operator a double star. Double star denotes as exponentiation operator 2, in the sense a into a, 2 times a. The result is a into a, it's nothing but a value is a 4. 4 into 4, it is a 16. Okay, the result is 16. Suppose when you are using a double star, okay, we can say that's exponentiation operator, then 3, then we can say that a into a into a, it is 3 times multiplication of a. The result is 60. The result is 64. Then next, okay, you can also use the unary, plus, minus, and complement. Then say for example, if I am saying that a is equal to unary minus, in the sense minus 5, okay, it is a unary minus. When you are printing a, then in the prefix you can have a sign operator, okay, we can say it's a unary minus. Okay, default the unary plus you can put plus, but compiler it ignores because it is a positive number. And we can go and discuss about arithmetic operator. Here it works based on BODMAS rule. Then you already know that it's a parenthesis, exponentiation, then multiplication, division, addition, and subtraction. According to the BODMAS law, it works. Then say for example, if the expression is just like 10 plus 2 into 50 divided by 5 and minus 7, then according to the operator precedence it works. First it works for this multiplication. The result is 2 into 50, it is 100. 100 divided by 5, it is a 20. And then 10 plus 20, it's 30. 30 minus 7, we can say that 23. Okay, you can check the result. Okay, the result is 23.0. When you are using slash, okay, it performs the division operation. It returns the floating point result. That's why the last result or end result is like 23.0. Suppose, say for example, I want to get only the integer result, integer division, then 5 double slash, then divided by any number. Okay, I can use 2. The result is, okay, instead of getting the result as a 2.5, I am getting the result as a 2. You can see that's a floor division. Next we are going to see the bitwise operator. For the bitwise operator, okay, you need to understand the logical gates in the digital logic. Just like it is a inverter. Whenever the input is given, it is inverted. Say for example, when you are giving the input as a 0, then it converted into 1. When you are giving the input as a 1, it converted as a 0. Okay, we can say that it's a negation. And the AND operator, here when both A and B are 1, the result will be 1. In either case, the result will be 0. If it is OR, if A and B, both inputs are 0, the result will be 0. Otherwise, okay, the result will be 1. Either of the input is 1, the result will be 1 in case of OR. And XOR, if both A and B are same, either it is a 0 0 or 1 1, the result will be 0. If any one of the input is 1, if any one of the input is 1, okay, in the sense A is equal to 1, B is equal to 0, or B is equal to 1, A is equal to 0, then the result will be 1. Okay, we can use the XOR. Now we are going to demonstrate the bitwise operator. For that better understanding, I have to use a notepad for demonstrating bitwise operator. Okay, I have to take x is equal to 6 and y is equal to 12. When you want to do bitwise manipulation, the compiler it convert the given decimal number into what we can say that binary number. Okay, how you have to convert this decimal number into binary? I can use the code in general 1, 2, 4, 8, 16, 32 and then 64, 128. Okay, with the help of this short code, I can easily convert given decimal number into binary number. So I have to write the structure. Okay, one for this sake of understanding, 128, 64, and then I can use 64, 32, 16, 8, 4, 2, 1. Okay, with the help of this code, you can easily convert the given number into binary number. Say for example, I want to convert 6 in the binary form. Then where we are to get the value of 6? Okay, when you are placing the 1 in the position, the fourth position as well as the second position. Okay, the rest of the place you can put 0. Here is also 0. Here is also 0, 0, 0, 1, 1 and 0. Okay, the literal meaning. Okay, now this binary number has the decimal value of 6. Similarly, we can find the binary value of 12. Then when you want to find the binary value of 12, okay, in the bit position 8 bit position we have to place 1, and then the fourth bit position we can place 1. All the rest of the places it stores the 0. Then 128 bit position is 0, and then 64th bit position is 0, 32 bit position is 0, 16th bit position is 0, then 8th bit position is 1, then 4th bit position is 1, the second bit position is 0, and first bit position is also 0. Then this is the binary representation for the 12. Now I want to do a bitwise AND. Okay, bitwise AND. Then in the sense A and B. Okay, what is the exact result we need to get? We already told you that if both inputs are 1, the result will be 1. Okay, otherwise we can say that the result will be 0. Then I can say that both, this is the x, this is the y. Okay, 0 0, the result will be 0 in the bit position 128. Then the 64th bit position is both inputs are 0, the result will be 0. Then 32, the bit position is 0, 16 0, then it is also 0. Look at in the bit position 4, both x as well as y, the value of 1. If both inputs are 1, the result will be 1 in case of AND, bitwise AND. Then either case you have to put 0. Okay, what is the result of this binary number? It is just like a 4. Okay, that's why when you are using bitwise operation, x is equal to 6 and y is equal to 12. When you are applying bitwise and x and y, the result will be 4. Next, when you want to find the result of bitwise OR, then how you have to find the bitwise OR? A pipeline symbol and then B. Okay, we can say that it's a bitwise OR. The constraint for bitwise OR, both inputs are 0, the result will be 0. Either case, any one of the input is 1, the result will be 1. For that, in the bit position 128 bit position, both inputs are 0, the result will be 0. The 64th bit position is 0, and 32 bit position is 0, 16th bit position is 0, and the 8th bit position, first number has a 0 value, but second number has the value of 1. Either case, any one of the input is 1, the result will be 1. And if both inputs are 1, the result will be 1. And here is also either case, any one of the input is 1, the result will be 1. Then both inputs are 0, the result will be 0. Now this is the binary representation for XOR. Then it is converted into decimal. What would be the result? In the sense, okay, in the 8th bit position we have a value of 1, 4th bit position the value of 1, and then second bit position the value is 1. Okay, when you sum it, then 8 plus 4 plus 2, okay, we can say that the result is 14. Okay, we can check X OR operator Y. Okay, the result is 14. Next we going to see going to apply what we can say that it is a X and Y. X and Y. Here we can use X and Y. Here is also X and XOR Y. Okay, next we need to find the logical XOR operator, then X cap and then Y. Then in that case, okay, if both inputs are 0 or both inputs are same, the result will be 0. Then if any one of the input is 1, the result will be 1. And 128 bit position, both inputs are same, the result is 0. In the 64th bit position, both bit positions are 0, the result is 0. In 32 bit position, both inputs are 0, the result is 0. In 16th bit position, both inputs are 0, the result is 0. Now in the 8th bit position, the first number is the bit position is 0, second number bit position is 1. So if any one of the input is 1, the result will be 1. Then in the 4th bit position, both inputs are 1, okay, then the result is 0. Then in second bit position, the first number is 1, the second number is 0. Then if any one of the input is 1, okay, the result is 1. At last, the first bit position, both inputs are 0, the result is 0. Okay, this is the binary representation for XOR operation. Okay, 8th bit position has a value 1, and the second bit position the value is 1. Then when you add it 8 plus 2, then the result is 10. Okay, you can check X cap operator and then Y. It is a 10. Next is a complement. Okay, complement, if I want to find the complement, in the sense it is converted zeros into 1, ones into 0. Okay, we can say that it's a complement. Say for example, if I want to find the complement of 6, okay, complement of 6, then you can put 1. Look at this is a 6, binary 6. Okay, complement in the sense 0 is converted into 1, 1 is converted into 0. then you can put 1 in the 128 bit position, you have to put 1. Okay, what is the operation we have to apply? We can apply complement, x complement, in the sense in the 128 bit position it is a 0 is converted into 1, then 64th bit position it's a 1, then 32 bit position is 1, and 16th bit position is 1, and 18th bit position is 1, sorry 8th bit position is 1, and 4th bit position is 0, and second bit position is 0, and the first bit position is 1. Okay, now this is the result of what we can say, that this is the result of x complement. Okay, then here this representation in the prefix all filled with okay, what is the value? Okay, we can say that it is a 1. Okay, we can say that this representation, we can say that it's a signed extension. Okay, first this type of calculation we can do with the help of okay, okay, now we can check what is the result we expected. X complement, x complement of x, the result is a -7. Okay, you can, when you want to write the -7, how the -7 is look like. Say for example, if you want to find the -7, say for example x is equal to -7, I want to find, then in general when you want to find the -7, first you have to write the what is the positive value of 7, then 0 0, you can place 32 bit position is also 0, and 0 0 1 1 1. Okay, this is the positive or +7. Okay, now when you want to convert the positive 7 into -7, okay, we need to take 2's complement for the given number. 2's complement for the given number. How you have to take the 2's complement number? Okay, take 1's complement and you have to add 1, then 1 1. Okay, I want to take 1's complement, that's why I have to convert zeros into 1, 1's into 0. Okay, I have to take, this is a 1's complement result. This is the 1's complement result. Then it should be added with 1. Okay, in the last bit position you have to place 1. Then when you add, okay, what is the result we expected? When you want to add this number, in general you can how you have to add. Okay, you can also start from the least significant bit. Okay, 0 and 1, the result is 1. Then 0 0, the result is 0, and again you can put 0, then 1 1 1 1 1. Okay, now we can have the result. Okay, it is equivalent -7. Look at what is the value we get from the complement. Complement of x is -7. Okay, the same result we can also have. Okay, this is, we can say that it is a -7. Next we are going to see we can apply left shift operation and then right shift operation. When you want to apply left shift operation for x is left shift 2 times, in the sense the bit positions are left shifted 2 times. Before that you have to write the value 128, so that we can have a clear understanding. 128, 64, 32 and 16, 8 and then 4, 2, 1. Then the x value is just like a 6. Again put 1 for the bit position 4 as well as 2, all others are 0. Then we can say that it is a 6. Now we need to left shift 2 times. Okay, we need to do left shift 2 times. Okay, this is the first time doing the left shift. Okay, say for example it's the first time I am doing the left shift operation. In the sense, the most significant bits are left out. Okay, then 0, 0, 0, 0, and then here this 8 it's the value from the 4, and because we are doing one bit moving off left side, and the second bit position we have a 0, and in the least significant bit we have to add a filler as the 0. Okay, this is the first time left shift operation. When you are doing the second time, okay, then here we have 4 zeros. Okay, then the leftmost 0 is truncated, then only 3 zeros are left, and then in the 8th bit position, okay, 8th bit position moves to value 8th bit position value moves to 16th bit position, and the 4th bit position value moves to 8th bit position, and the rest of the values are you can fill with 0, right? The second bit position is copied to 4, then first bit position is copied to the second position as a 0, and the filler is a 0. Okay, what is the result of this bitwise left shift of x less than left shift of x is 2, then the result will be, you can calculate, okay, 16 plus 8, the result will be 24. Okay, you can check the terminal x is less than 2. Okay, the result is 24. Similarly, you can do what we can say that it is a right shift operation. Say for example, x is a right shift 1 time. Okay, then first we know that this is x value binary representation. We have to do a right shift operation, in the sense that the least most significance are removed each iteration. Okay, we need to do only 1 time. Then in the leftmost, the filler value is added as a 0. That's why the here we can start with in general we can start with LSP. Okay, this 0 is moved away, then this 2 is dragged into the first bit position. Okay, 1 and 1, and 0 and 0. Okay, 0. Okay, the filler at the most significant we have to add the filler as a 0. Okay, now this is the after right shift operation. Okay, 1 time right shift operation, the result does look like. Okay, then it is the value of 3. Okay, we can check x right shift operation 1 time. Okay, the result is 3. Okay, this demonstrates the bitwise operator. The next is just like a a relational operator or a comparison operator. The relational operator in the sense, okay, it checks the relation, okay, whether A is less than B or X is less than B, X is greater than B. Okay, you can check. We can take two objects and you have to compare it. Okay, we can also term as a comparison operator. Say for example, now I have to take X is equal to A is equal to 5 and B is equal to 10. Okay, I want to check whether A is less than B. Yes, the condition is true. Then I can say that A is greater than B. Now, okay, it is not true because it is a false. Then you can say that A is less than or equal to B. Yes, B is the 10, A is the 5. Okay, it is ultimately less than 10. Okay, there is something to be true. Then we use A is greater than or equal to B. Condition is false because B is a value of 10, A is 5. Okay, then A is not at all greater than or equal to B. Then the result is false. You can also check it. A equal to B, it is also false. Okay, but when you are saying that A not equal to B, the condition is true because both integers are different. That's why the result is true. Okay, next operator we are going to see is the identity operator. We already know that how we have to check the identity of a particular object with the help of an ID. Okay, ID of A has the memory location 736 and ID of B as the memory location, it is suffixed with A96. Okay, you can check both A and B are object. It is a same object, both objects are referring the same integer value. Here you can check A is B. Okay, the condition is false. Suppose if A is not B, now the condition is true. Suppose say for example C is equal to A. Now A is C. Here both C and A referring the same integer object. Okay, what is the integer object value? It is nothing but it is a 5. Okay, we can say that this concept we can say that it's object pooling. Next we can use in and not in operator. Say for example, I can say that 1 in a range of 6 is definitely is in the range. Okay, it starts from 0 and it moves up to 5. Okay, then it is always true. Okay, then if I am saying that A is some string, say for example welcome, A is a welcome string, I can check whether E is available in the particular string. E is in A, it's true. If I am saying that some other value, then saying the within a single quotes I can say that D in A, okay, whether the D character which is available in the welcome string, it is not. Okay, then the result is false. Okay, we can say that it is in operator. Similarly, you can use not in operator. Say for example, L not in. Okay, L not in A. Sorry, L not in A. Okay, the condition is false because L is available in that string welcome. Okay, L is available. Okay, not in the sense the condition become false. Then you can use a logical operator. Say for example, I can compare more than one operands. Say for example, A is less than B and A is less than C. I have to reset the cell. You can place the A is equal to some value, say for example 5, B is equal to some value 3 and C is equal to 2. Then when you want to compare these values, okay, A is less than B and A is greater than A is less than C. Okay, here the condition is false because A is the 5. It is the biggest among these two numbers B and C. Okay, when you say that A is greater than B and A is greater than C, okay, the result is true. Okay, similarly you can use OR operator. Say for example, if any one of the condition is true, then the result will be true. A is less than 5, the condition is false. Or okay, less than B, okay, the condition is false. Then A is greater than C. A is greater than C. If either case any one of the condition is true, the result will be true. The NOT operator, what we can say that you can complement it. Say for example, NOT of C. Okay, then C stores the value of 2. NOT of C, then it changes the result into false, because it has some true values are available. When you negate it, you can have a false value. Similarly, say for example, D is equal to 0. Not of D, then the result will be true because D is the false value. When you negate it, you can have a true value. Okay, these are the operators are available in Python. Next topic, we are going to see flow control statement. Flow control statement. There are 3 types of statement: sequential statement, conditional statement, and looping statement. Sequential statement in the sense the executions of set of instruction one after another. It follows in a linear manner or linear fashion. The execution order is not altered anyway. Okay, we can say that it's a sequential execution. Then what we can say that it's altering of program execution, program flow. Okay, we can say that it is a there are 2 ways to alter. Either we can use a branching statement or you can use looping statement. That's why the program execution flow is altered based on the condition. Either it's a branching or looping. Okay, we can see the demo on P1. See for example, if I want to add 2 numbers, okay, then I can get A is equal to int input of enter A. Similarly, I want to get the B value. B equal to int of input of enter B. Okay, I need to print the result. Print result. Okay, I want to print A plus B. Okay, we can say that it's a sequential statements or sequential execution. The program flow is not altered. When you are running the code, run module, it getting the value of A is 10 and B is 20. The result is 30. Then suppose if I'm using the branching statement, okay, in the branching statement we can have a simple if else, then else if ladder, and nested if. Okay, these are the different type of branchings are available. Okay, we can see one by one. If I'm saying that this program to find the given number is odd or even. Okay, for that find the given number is odd or even. Okay, here when you're using the as symbol, then we can say that it's a command. It's a single line command. Okay, I want to get the number first. Okay, n is equal to I want to convert the number into integer. I can use the typecast operator int of and then input of, and you can say that enter the number, enter the number. Okay, after getting the number I have to check if n is divisible by 2, in the sense the given number is even number, so n is divisible by 2 equal to 0. Okay, here it is the modulo operator. Okay, it returns a remainder. Then the remainder is equal to 0. The given number is even. Else you can say that the given number is odd. The given number is odd number. You just save the program and run the module. It gets a value. Okay, the number is there. For example, 99. 99 is the odd number. You have to do one more run. If I am giving the number as 100, okay, the result is a even number. Okay, this is for a simple if-else. Okay, you can also checking series of conditions. Say for example, find biggest among 3 numbers. Okay, for that we need to check the series of condition. A is equal to int of input of enter A. Similarly, you have to get the value of B and then C. You have to reuse the statement, so then you can have faster program practice. Stop typing each and every line. Once you know the concept, you can just replicate the content and do the manipulation. Now ABC are available. You have to check if A is greater than B, and I have to use a logical operator. A is greater than C. Okay, I decided that, okay, which one is big? A is big. A is big. Okay, what is the value of A? I can also print it. Elif. Okay, the series of condition checking. If the first condition is failed, you check the second condition. I check with the second condition. B is greater than C. Then ultimately, which one is the big? Okay, B is the big. B is big. If both A is not big and C is both A and B are not big, then ultimately C is big. Print C is big. You just save it and run the module. Getting the value of A is equal to 5, B is equal to 9, and C is equal to some value 1. Okay, the value is just like B is big. You can put nested if, presence if within another if, it is also possible. Okay, next we are going to see looping statement. Looping statement is used to execute certain set of statements repetitively. Say for example, this program display the numbers from 1 to 10 using looping statement. I can say that I is equal to initially 0, initially 1, and while I is less than or equal to 10, I can simply print I value, and you can increment I is equal to I plus 1. Okay, that's it, and you have to save the program. run it. Okay, these block of statements are executed repetitively. First iteration it prints I value is 1, then the next iteration is I is incremented by 1, then you have to check 2 is less than or equal to 10. The condition is true. Okay, till it reaches till it moves to 10, it printed. When the I value reaches the 11, it exits from the loop. Just run the module. Okay, look at we can have a result. Okay, it iterating the values from 1 to 10. You can also find the given number is palindrome. Then first you have to read the number. N is equal to int input of enter the number. After getting the number, you have to take some backup. Okay, it is equal to n. Then you have to make a reverse number is 0 initially, while n is not equal to 0. You have to iterate it. You have to find the remainder. REM is equal to n mod 10. You can get a remainder. Okay, the reverse is calculated. Reverse star 10 plus the remainder. Okay, when you are using this logic, okay, each and every iteration you can get the last digit, and it is summed with the reverse one. Okay, but the reverse star 10, it makes for the every iteration it is changing their position, digit position. Initially at the first bit position, then 1/10th bit position, 10th position, then 100th position. It's like you have to move. For that you have to use reverse star 10, and n is also reduced by n divided by 10. Okay, keep on doing it. You can check at last if the reverse equal to the temporary. We have a backup of n. Both are same. We can say that the print the given number is palindrome. Else here you can say that print the number is not palindrome. Just save the program and just you have to run the module. Okay, the number is there, say for example 51. When you are reversing the number, you can have a result of 15. Okay, it's not a palindrome. Okay, one more line. If I am saying that the number is 121, when you are reversing the number, we can also get the same number. This is the logic to find the palindrome. Next we can use a looping statement. Okay, for looping statement. Next we can discuss about. Next we are going to discuss about for loop statement. Then for there are two type of structures are available. For x in range, you can say that the start value is 1 and end value is the 10, and you can also step value is the 1. Then print x. Just to save it, iterate the for loop from 1 to 9. Because when you are saying that it is in position up to n minus 1, the iteration works. Okay, the result is just like start from 1 and it moves till the n minus 1. The n minus 1 in the sense now the n value is the 10 and it iterate up to 9. Then this is one format You can also, without specifying, if you are giving the single argument, okay, then it denotes we are giving the nth value. Okay, print of x, the same result we can get. Suppose I want to say that I can start with 1, end with up to, we can iterate 10, and the increment value is 2. Okay, that program, it prints only the odd numbers, because it starts from 1. For every iteration it is incremented by 2. Then 1 plus 2 is a 3, and 3 plus 2 it is a 5. Then the result will be displaying odd numbers: 1, 3, 5, 7, 9. Okay, with the help of a range function, you can use range in the for loop statement, and you can also use to iterate the collections with the help of a for loop statement. Say for example, A is the string, is happy is the string. Now I want to iterate the string, each and every character. For I in A, print of I. For the first iteration it returns H, for the second iteration it returns A, and keep on doing until all the characters are iterated. Okay, H, A, P, P, Y. Okay, here you can place the collection. You can go with a string, or you can go with a tuple. Say for example, I can use a tuple 1, 2, 3, 4, 5, 6. Then that occasion, then it iterate the tuples. For the first iteration it displays 1, second iteration 2, till the last element. You can iterate the collection as a list. Okay, then you can use a square bracket instead of parenthesis. You have to use a square bracket. We can say that it is a list collection. Okay, then when you run this program, it iterate the list value to find given number is prime or not. Okay, for that we need to write some logic. First we have to get the n value. Number n is equal to int of input of enter the number. After getting the number, okay, I have to check whether the given number is prime or not. Then I have to use a for I in range of 2 to n. You have to iterate it. You have to check if n mod I equal to 0, then the number is divisible by some other number, in the sense the number cannot be the prime number. So you can say that the message print it is a non-prime number, prime number. And then you have to exit from the loop. You can use break. You can use else case. Print after successful completion, there is no parts are executed. Then you can say that the given number is prime number. You just save the program and run it. The number is, say for example, 19. 19 is a prime number. You are giving the another number. Say for example, it is a 4. It is a non-prime number. You can use a dictionary to get some operation, just like in other languages they used multi-way branching. using switch statement. Instead of switch statement, we have to use a dictionary, and whether the content is available or not, we can easily check. Look at, I can say that print, I can use a dictionary. This can say 1 colon 1 2 colon EW2, and again the dictionary consists of 3 items, A colon 3. Okay. I have to extract get off with the help of get off function. I'm extracting the value 1, extracting the key value 1, then it returns the appropriate value. Okay, what is the key associated with 1? The result is ONE1. It will be written as a result. Invalid. Right? It returns the result as a 1. Suppose if I'm getting the value as a 4, whether the 4 key is available in that dictionary, it is not available. At that time it prints the invalid. Then here we can say that as a continue and pause. Okay, say for example, if I want to print the numbers of 1 to 10 for I in range of 10, if I equal to 5, I can use continue operator. It skips the current iteration, it performs the next iteration. Print of I. Okay, it prints 1 to 4. The fifth iteration will be skipped because we are using that continue. Then it continue with the next iteration. Then I is incremented with 6, and it prints from 6 to 9. You have to just save the program and run the module. Look at the result. 0, it starts from 0, and during the I values of 5, it is skipped the current iteration. That's why it does not print the I value, and it performs the rest of the iteration. Okay, you can see that it's a continue. Pause do nothing function. Some occasion, okay, we can use pause statement for later development. Okay, it is syntactically correct, makes the program syntactically correct. Break statement is used to exit from the current block, or exit from the inner, what we can say, it jumps out of the closest enclosing loop. Okay, next topic is the function. Okay, function is used to, in general, function is a block of statement that performs a specific task. It provides the reusability and breaking up the complex program into sub-problems. Functions are used to modularize the program. Okay, these are the features associated with the function. What we can say that if you want to solve the complex problem, when you want to directly approach the problem, it is very tedious to solve. Instead of that, we have to break this problem into sub-problems, and we can find the solution for sub-problem. At last, we have to integrate it, and we can get the final solution. That's why the function provides the modularity. Then, if you want to define a function in Python, you can use the def keyword, the function name, then open parenthesis, you can pass a set of arguments. The arguments are optional, and we can put colon, and we have a set of statements are there. And last statement, return, you can send some values, return expression. Okay, this return statement is optional. There are 4 types of function according to Python. The first one is the user defined function, defined by the user. It is defined by the user themselves. Built-in functions that are built in within Python. Lambda function functions that are anonymous or unnamed functions. A recursive function calls itself is known as recursive function. Okay, we can see one by one for user defined function and built-in function, lambda function and recursive function. Okay, first we need to see, okay, user defined function. I want to create an add function, def add of. Okay, it has a no argument initially, that is it does not getting any argument. Then I can say that a is equal to int of input of enter a value, and similarly I am getting the b value, int input of enter b, print a plus b. Okay, this function does not return any value. If I call this function add of, you just save the program. Okay, the function has no argument and no return value. You just run it. It asks for a value. A is 25, B is 75. Then the result is 100. And then the function has no argument, but if you want to return some value, I can say that if I want to return some value, return a plus b. Then this function is return some value. You can store it into some variables or you can directly print it. Print of, you can call add of function. Then we can say that function with no arguments, but it returns the value. Okay, it has a no argument or without argument, but it returns a value. This portion. You can just save it. Okay, this category we can say that this is user defined function. We are defining our own function. It's add. If I am saying that A is 10, B is 20, the result is 30. Then next function has argument. Say for example, def add, it has an argument a comma b. Print a plus b. When the function does not return anything, it displays the result. Before calling this function, we need to read a and b. That's why a is equal to int input of enter a, b is equal to int input of enter b. Then you have to call this function add of a comma b. Then when you run this program, it asks for a value. A is 10, b is 20. Then the result is 30. Suppose the function receives the argument. If you want to return the value, you can use the return statement. Okay, you have to comment the particular line. Instead of printing, you can return or return a plus b. Python is capable of returning multiple values. It is possible. In other languages is not available these features, but Python is capable of returning multiple values. Okay, print off and then add. You can pass the value. Just run this program. You can save the program and run it. Okay, you can give some values 75 and 50. Okay, the result is 125. Next, based on the keyword, based on the argument, Okay, there are four types in function based on the argument passing. Okay, there are four type of functions. Okay, say for example def my underscore sum, it has a four argument a comma b comma c comma d is equal to some default value as the 40. Okay, and it returns the result just like a plus b plus c plus d. Okay, the function receives the argument and returns the value. Okay, now you can call the function, say for example print of my sum. Okay, I am passing the value 10 comma 20 comma c is equal to 30. Okay, I didn't give the value for d, then it takes the value from default argument. Okay, what's the default argument value? D has the value of 40. It gets the value and it sum all four elements and it prints the result. Okay, the result is 100. Okay, we can say that these are the positional arguments. Okay, the 10 is passed to the a, 20 is passed to b, and c is the keyword argument. Based on the argument name, we are passing the value. It's a 30. So that is assigned to the c, and d, we are not passing the d value. Then it gets the d value from the default argument, and at last it sum all four elements and it returns the result. So the result is 100. Suppose you can also change the if I am saying that d is equal to 50 instead of 40, I can say that directly I am giving the value d is equal to 50 and c is equal to some other value, say for example 90. Okay, what happened here? I am not following the positional order. Okay, positional order. Instead of that, I am using that d equal to 50. I am using the key word arguments. Okay, then the keys matches with the function protected. D is available, then it is replaced the current value of d with the 50, and c argument is available, then it is it stores the value of 90. Then you have to submit, you can get the result. This is 140 plus 30, 170. Here there is no need to follow the order. Okay, look at the positional argument, the values get assigned as per the sequence. Keyword arguments are those arguments where the values get assigned to the arguments by the keyword, Then default arguments assign the default value to the argument using the equal to operator at the time of function definition. At the time of function definition, okay, we have a d is equal to 40. When you are missing the d value, then it takes the default argument value. The next one is nothing but a variable length argument. Def my details. Okay, I need to pass the names. Print name. My underscore details. It is capable of getting variable length arguments. Say for example, the name is Raj and Alvin and Haja. Okay, you can pass any other valid name. You can say that Ram. Okay, we are passing the four arguments. Okay, just you have to save the function and run it. Look at it, prints Raj, Alvin, Haja, sum. We want denote variable length argument before the argument name. Okay, it is prefix with star. Okay, it is prefix with star. And star has a multiple meaning. Okay, it performs the multiplication, it performs the repetition operator. Here print of star name, here it is used to disclose the tuple values. Variable length arguments. If we want to specify more arguments, when specified while defining the function, the variable length arguments are used. It is denoted by star symbol before the parameters. Parameter or argument. Okay, it is mentioned. Then we can say it's a variable argument. Next is a lambda function. We already told you that lambda is just like an anonymous function. This is used for performing simple calculation, not for complex operation. Example, I want to define a lambda function. F is equal to lambda of x comma y colon x plus y, and f of 10 comma 20. 10 is assigned to x and 90 is assigned to y. Then the result is just like x plus y. Then 10 plus 90, the result is 100. Okay, you can call lambda function, it returns the result. Okay, I can store the result variable, and you have to print the result. Print of result. You just save it and run the module. Okay, then the result is 100. Then here we can say that it's a function overloading, just like we earlier discussed, def of add of x comma y comma z, then return x plus y plus z, right? If print of, you can say that add 10 comma 20 comma 30. Then here this add function that performs the integer addition, it returns the result. The result as what we can say that 60 as the result. Then print add of some strings are given, just like b, and then y is mk, and z is equal to b. Then that time it concatenate all these strings. The result is bmkv, and print of add. Suppose if I am passing the floating point numbers, say for example 5.5, then 4.5, then 15.5. Okay, the expected result is 12.5. Okay, we can check. Just have to run the module. Okay, 60 bmkv and the floating point addition. Okay, in this scenario we can say that's a function overloading. The same method based on the argument type, it works. Then next we can say that function composition, in the sense a function call another function itself. A function call another function. We have a two function, def add, it has a two argument a comma b, and it returns the result as a plus b. Similarly, another function, it is a mul. Okay, it has a two arguments c and d. It returns the multiplication c star d. Here I want to call, okay, in the print I have to call mul of c value is the 10, and within that I have to call add of 10 comma 40. When you are passing the value 10 comma 40, The 10 comma 40 returns the result as a 50. 50 into 10, the result is 500. It is a function composition, a function call another function within it. Okay, the result is 500. Okay, the next, for better understanding of a map function, I have to create a list. Okay, list L is equal to, I can say 1, 2, 3, 4, 5, and I have to square the list items. SQ is equal to list of, I can use map function, and then I have to pass lambda. I can take each and every value and it should be squared. And X, you can use exponentiation operator, double star 2, and then it is applied to the given list L. Okay, print SQ. Okay, this program demonstrates the map function. It gets the value from the list and it is squared and it is stored in the same list. The next one, demonstrate filter function. It filters only the numbers which is less than 0. For that I have to create a number list NL. Okay, I can use the range function. Okay, -5 to +5. Okay, it is a range of values are available in L, and then I have to filter the less than number. Okay, less than 0. Okay, LZ is equal to list of filter function. You can use our lambda x colon x is less than 0. Okay, those numbers alone stored in number list, and you can print less than 0 number list alone. And last is nothing but a reduce function. From function tools import reduce. You can find the product. Product is equal to reduce of, you can use reduce as a 2 argument. One is the lambda function. Okay, it is nothing but the x comma y in turns it redistributed into x star y. Then another one, we can apply the list. Okay, I can apply the list L. Okay, the L is equal to 1, 2, 3, 4, 5. Okay, you can redefine it. So for example, L2 is equal to 1, 2, 3, 4, 5. Okay, you can use L2 list. And this L2 list is condensed, and at last we can have a final result. Okay, next we are going to see how we have to work with a recursive function. The recursive function, in the sense a function call itself to get the results. In the recursive function there are two cases. One is the base case, another one is the recursive case. Base case is to stop the iteration, and the recursive case is calling the function itself again and again. Okay, say for example, if I am calling the factor of 5, okay, it is moves the recursive call just like 5 into factor of 4, then this factor of 4 is recursively called 4 into factor of 3, then the factor of 3 is recursively called the 3 into factor of 2, until it reaches 1 into factor of 0. Okay, say for example, if I want to use this recursive function, how it is stored. the order of execution, like it start from factor 5 to factor 0, it moves, and then the execution order is reversed. Then it gets the result from factor 0 first, and then it is multiplied with factor 1, and it is multiplied with factor 2. At last we can have a final result. And if I want to demonstrate factorial function, def fact of n, and I can use if n equal to 1 or n equal to 0. Okay, both the cases, okay, we can return the result. Okay, return 1, because 1 factor is 1, 0 factor is also 1. Else you can return n into fact of n minus 1. Okay, we can say that it is a recursive call. This is the base case. Okay, this is the base case, whereas it is a recursive case. It is a recursive case. This is a recursive case. Then here we can say that it is a base case. Okay, base case is just to stop the iteration, and here we have to call this function print of fact of 5. Then you have to just save the program and run it. The result is 120. Okay, thank you all for watching the video.